Hello everybody. So we need to determine the equation of a hyperbola. There's two types of ways they can ask a question like this. So here's the first one. Determine the equation of a hyperbola where 5, 2 is the point where both asymptotes intersect and 3, 3 is a point on the hyperbola. Guys, I saw that asymptotes was still there, but I decided to leave it because, like, why not? You know, at this point, screw it, man. We all have free will, man. Come on. It's just, let's hope that they don't do that in the examination. So let's answer the question. What are we given? We are given the point where the two asymptotes intersect. What is that? Where we have x, y, we have 5 and 2. How do we visualize that? Well, notice when you want to visualize that, right? What you are going to end up looking at is something like this. Okay, so what did they say? 5 and 2. So x equals 5. So let's say here, and then we have x equals 5, and then we have y equals 2. So let's say it's somewhere over here, and then here. And then this is the point that they both intersect. So what would it look like? It would look something like so, where we have x equals to 5, and then we have something like this, where we have y, that doesn't look like a y is equal to 2. Does that make sense? Because they can only ever be perpendicular to each other, the asymptotes. They only intersect each other at one point and one point only. So that would indicate to us that the vertical asymptote is going to be x equals 5. So what we are saying is x equals 5 implies vertical asy, and y equals to 2 implies to us that we have a horizontal asy. Okay. Now we need to use this information and put it into our standard equation. We know the standard equation is y is equal to a over x minus p, and we are going to have plus q. And we know that our p value is essentially just this, right? This is our p value, and this is our q value. Because the p value is our vertical asymptote in the x, shifting in x, and q is our horizontal asymptote shifting in y. So therefore, what we can say is, this implies to us we have y is equal to a over x minus 5, right? Because p is directly equal to 5, and this will be plus 2. Now what? We want to solve for a, but we don't have x and y, or do we? Remember, we know the point of intersection of the asymptotes is 5, 2, and it says, and 3, 3 is a point on the hyperbola. So we'll just plug in the point 3, 3. Okay. So therefore, we sub 3, 3 into our equation. So let's call this 1. So into 1. Okay. So from here, when we sub 3, 3 into the actual equation, we are going to have what? 3 is equal to a over 3 minus 5 plus 2, because we just substituted our x and y values. So then from there, what this implies to us, if we take the 2 over, it'll become 3 minus 2, which is just 1. And then here we're going to have a over 3 minus 5. 3 minus 5 is just negative 2. Then all we're going to do is multiply both sides by negative 2, such that we have a is equal to negative 2. Okay, so therefore our answer is going to be y is equal to negative 2 over x minus 5 plus 2. Was that difficult? No, it wasn't. I don't know if you should leave it in the form of f of x equals, but the question never said so. So that should be fine. And that's how to answer the first type of question for this one. Let's go into another type. So here's another type of question. So determine the equation of a hyperbola with points negative 3, 7 and negative 7, negative 5 with vertical asymptote x equals negative 4. So here's a problem. If they give you any function with two random points, you know you're going to be doing simultaneous equations. And yeah, we are about to be in for a treat. and then they give us x equals -4 to be the vertical asymptote. So what does that tell us? It tells us that our equation as of now is going to be y is equal to a over x, and then we know that p is represented by this, right? Our p value is going to be shifted -4, so 4 to the left for our asymptote, basically. So we just plug in -4 for our p. So minus into -4, okay, because it's x minus p, plus q. And then from here, we can just simplify it and say that y is equal to a divided by x plus 4, okay, plus q. Alright, so what are we missing? We're missing a lot of things. But remember, whenever we're given random points, we don't have to worry too much about the x and y. We want to solve for a and q, but we're probably going to have to do simultaneous equations since they gave us 2 coordinates. So what we are going to do is we are going to sub in, let's say -3 and 7 into, and then let's label this equation 1. So we're going to sub it into 1, okay? So now from here, what we are going to do is we are just going to sub in and then simplify as much as we can, okay? So then from here, we have what? X is equal to -3 and y is equal to 7. So therefore, 7 is equal to a over x, which is equal to -3 plus 4 plus q, okay? Then all we need to do is, I would recommend letting q be on its own for this one. Since there's no coefficient in front of q, we can solve for q. Meaning, we can have q equal to that, and we can take the a whatever over to the other side, such that we'll get 7 minus a over -3 plus 4 is equal to 1. So therefore, q is equal to 7 minus a. Alright, now we got one of our equations. So let's just call this 2. Now we're going to sub in the other point. So sub in, what was it? -7 and -5, right? I hope so. -7 and -5, 100%. Into 1. The original one that we had, right? Because 1 was equal to this incomplete equation. So once we sub that in, okay, all we are going to do is we are going to just say what? We have x is equal to -7 and y is equal to -5, such that what we're going to have is -5 is equal to a over -7 plus 4. And then this is plus q. So when we're solving, we are going to let q be on its own because it's, once again, it's easier. Because q has nothing to mess it up. So therefore, q is equal to, we take this over on that side, such that we have -5 minus a over -7 plus 4 is equal to -3. So then what this tells us that q is just equal to what? -5 plus, because the negatives cancel, it's plus, let's say a over 3. Okay, and we can call this number equation number 3. And now that we have 2 equations in the form of q equals 2, we can let them equal to each other. Okay, we use the q equals q method such that what we're going to have is, okay, on the next page rather, we are going to say, we're going to tell the person we're going to equate 2 and 3. Okay. We're going to equate 2 and 3. And then what's going to look like is going to look q equals q, which is just going to be 7 minus a on the left hand side for this one is equal to, what's the other one? -5 plus a over 3. Okay. And then from here, what are we going to do? So you'd probably think like, what are we going to do here? But it's actually not that bad. Here, let's just take the constants over there. So the -5 can go over as +5. So 7 plus 5 is on this side. We take the -a over to the other side. So therefore it will be a over 3 plus a Okay, but a over 3 is the same as saying a third times a. So you could say a third times a plus a. Okay. And if we simplify, 7 plus 5 is equal to 12. And this is just going to be equal to, if we take out a common factor of a, then we're left with a third plus 1. Okay. And what is a third plus 1? If we look at it this way, 1 over 3 plus 3 over 3, this is equal to 4 over 3. So a third plus 1 is 4 over 3. So it'll be 12 equals 4 over 3 times a. And we want to multiply both sides by the reciprocal of this fraction. So therefore, it's going to be 12 into 3 over 4 is equal to a. And therefore, our a value is just going to be equal to what? The 12 will cancel the 4. So 12 over 4 is just going to be what? 3 over 1. Okay. And then we're going to have 3 times 3, which is just going to be equal to 9. Now that we know what our a value is, we need to find our q value. We can plug it into number 2. So we're going to say here, sub a equals 9 into our number 2. Okay. Such that q is equal to 7 minus a, which is just 9. And this is just going to be negative 2. Okay. So that is how we find the q and the a values. Right. And then therefore, because you know all our values, we can say therefore y is just equal to, what is a equal to? A is equal to 9. So y equals 9 over x plus 4. So I had to look back quickly, sorry. And then it will be minus 2. So that's our q value. And there is our equation.